Hello, let's do the New York Times Hard Sudoku for December 18th, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. We've got 2, 4, 7, and 9 here. So we have two 2s looking down. This 2 looks in, putting a 2 in one of these two. Horizontally, not much going on, but this box is empty, so we're not going to find a whole lot. These two 4s look down. This 4 looks in. That places the 4 in this box. These two 4s look in, this 4 looks up, placing 4 in this box. These two 4s look up, putting a 4 in one of these two. All right, let's just take a look at 4s real quick. So 4 is in one of these two, and in this box it's in one of these two. So we've got this kind of standard turn the corner, 3 digits left, where once we find one of them, it'll resolve all the other ones. All right. So that was 4. How about 7? 7 is in one of these 3. Vertically, there's not much going on with 7s, actually. Okay, so that was 2, 4, 7. How about 9? All right, 9's in one of these 2. That's going to point into this box along with this 9, putting a 9 in one of these 3. I'm just going to look at what looks into this box as well to see if there's anything interesting. So 2, 4, 6, 8. So we have the 4 already. The 2 6s look up, putting a 6 in one of these two. And the 2 8s look up, putting an 8 in one of these two. All right. 4, 6, 7, 8, 9. I'm wondering if these 3 cells are limited enough to look at, but let's not look at that yet. Let's get the easy stuff first. This cell, though, I do want to look at because it's not the 1, 6, 7, 8. It's also not 4, 9. So that's 6 digits that automatically it isn't. And I'm seeing the 5 look in as well. So it's not 1. It could be 2, 3. It's not 4, 5, 6, 7, 8, 9. So it's just down to 2, 3, which is what I expected, given that it wasn't 6 digits in the box and it wasn't a 5 either. So it was down to 2 digits. All right. Always good to match what you penciled with your expectations. It's any little checks you can have can help reduce human error. All right. Because we are all human and we all make errors. Let's see, 1, 6, 7, 8. So I see 6, actually. Yeah, we have 2 6s looking in. This 6 looks down. 6 is placed there. I was seeing 1 6 here, 1 6 here, which wasn't all that interesting, but it did end up being interesting. There's a 1 in one of these two. That points down with this one. We have another empty box down here, by the way. Anything else look down? Yeah, the 2 8s look down with this 8, putting an 8 in one of these two. My congestion's getting really bad. I'm doing my best here. We have the 2 6s looking down with this 6, putting a 6 in one of these two. So 1, 6, 8, 9, 8, 7. All right. Is there anything else up here I want to look at? Does anything look... Yeah, this 3 looks up through here. I was going to say, we have a filled box column. So we actually want to look at both of these columns here. And we want to pick out any digits that aren't already placed. So 4 is placed, but 3 and 5 are not. So just one at a time. The 3 looks up into here, putting a 3 in one of these two. That's going to point down with this 3, putting a 3 in one of these 3. The 5 looks up, putting a 5 in one of these 3. That points down with this 5, putting a 5 in one of these 2. All right. Anything else in this band that I might want to look at? I think we're good to move on for now. Let's do the 2, 3, 4, 6 here. So 2. We do have 2 3s. That's actually very helpful because it places the 3 in this box. So 3 digits left in this box. Let's just take a look. We need a 1, we need a 2, and we need a 7. All right. So 3 digits left in this row. We need a 5, 7, 8. We know that's not 8. That's all I see. So the 8's in one of these two. We knew that from buddies also. This row's down to 4 digits. We need a 1, 2, 7, 9. This can't be the 7s or the 2. So this is 1, 9 only. This can't be 1, so it's 2, 7, 9. This whole box is 2, 5, 7, 9. So this is 5, 7, 9. So he's a 2. This is any of them. All right, what else can I find here? I already did this vertical scan. Let's just make sure I didn't miss anything. Okay. Not much to scan vertically here. I think that might be it for this band. Let me just make sure I didn't miss anybody. So we got 2, 3, 4, 6. Not the 2. 3s are done. 6s are done. 4s are done. 1 and 8. We got the 8s. Okay. I think we're good. What about this cell? It's not the 2, 3, 4, 6. It's not the 5, 8. So yeah, what is it? It could be 1. It's not 2, 3, 4, 5, 6. It could be 7. No, it can't be 7, actually. The 7 looks down. Ooh, okay. So this is going to be a 1-9 pair. And the other, I can show you another way we could have seen that. So it can't be 7. It can't be 8. So this is a 1-9 pair for the column and the box. But we could have also seen that we had the 5s and the 8. Losing my voice. Excuse me. I apologize, but not much I can do. Drink of water. So we have the 5 and the 8 limited to these 3 cells. I mean, 5 can't be here, 8 can't be here. But if I highlight these 3 cells, I must place a 5 in them, and I must place an 8 in them if I'm going to put a 5 and an 8 anywhere. And so if we look, the 7 looking down does the same thing to the 7. If we were to corner mark it, we'd corner mark 7s in these 3, but I would not do that. It's a confusing shape to have corner marked. You might start thinking of pointing going on when you don't. And so one of these 3 cells needs to be a 5, one of them needs to be a 7, and one of them needs to be an 8. 3 cells can only have 3 digits, so that removes 1 and 9 as options from these cells, leaving just 1, 9 over here. But we can see the opposite side of the coin, which is that if we pencil these 2, they are a 1-9 pair, and that removes 1, 9 from the rest of the column and 1, 9 from the rest of the box. So this is down to 5, 7. It can't be an 8. And the 1-9 pair for the column is 3, 6, 8. I'm going to write it out. We know this one can't be 3 because we had the pointing 3s or claiming 3s. And this can't be an 8 and that can't be a 6. All right. I think that's all we get out of that 1-9 pair. Not 1, not. So these aren't 1. Oh, okay, so 1 in this box now is in one of these 2. That's going to point down with this 1-9 pair, putting on one of these 3. None of these are 5. So these are down to 1, 3, 7, 8. So this is 1, 3, 7. All right, what about this band here? 4s, 5. Is there anything else to do in this band? There's not like an immediate obvious thing to do here. Okay, so obviously we haven't finished the puzzle, so our initial pass seeded us with a lot of good stuff, but we haven't finished the puzzle. So what we're going to do is we're going to go on to our next systematic pass here. So I'm going to go row by row, and I'm looking for a few things. One is I'm looking to see if there's any pairs or triples I might have missed in those rows. It does happen. And then the other thing that I'm looking for is if all the cells in the row might be worth marking, or if some of the cells in the row might be worth marking. Oh my gosh. Okay. So I'm just going to go through this. I'm not seeing anything with rows. Columns, I'm more likely to spot something because I pay much more attention to rows than columns in my initial pass. So we know the 3s are, yeah, there. Let me just look at this whole box. We need 1, 3, 5, 6, 8. So we know these aren't 3. So these are down to 1, 5, 6, 8. So this can't be 1 or 6. So this is 5, 8 only. This is 1, 5, 6 because it can't be 8. This can be any of those. All right. Anything else of note here? I looked at this column already. I'm pretty sure. All right. We might want to ask the question, do we have a 5, 7, 9 triple? We just need one more cell that's limited to 5, 7, 9. We'd have that triple. It might be tough in this column. I don't know if it's going to happen. It probably won't. But the way you can check is to think about what are all the other digits besides the givens, the 2 and the 8, and besides 5, 7, 9. So those are going to be 1, 3, 4, 6. And 4 digits is what we expected because there are 5 open cells besides where we have our 2 in the triple. And one of them would be used by the triple, meaning there's 4 other digits to account for. So again, that's going to be the 1, 3, 4, 6. So we know 4 and 6 can't go down here. So we would just need to see 1, 3, but we don't. Up here, we're not going to see anything. So no, there is not a 5, 7, 9 triple. The fact that 4, 6 isn't here, we already have it marked up here. Unfortunately, it doesn't do anything on its own. I'm going to check out this column because we know these aren't 7, 9 because of the corner marks. But we need 7 and 9 in the column. But, oh, it's just down to 4 digits anyway. We need a 2, 5, 7, 9. So since these aren't 7, 9, this is where the 7, 9 go. This is a hidden 7, 9 pair, and this is where the 2, 5 go. All right. Remember, we had these pointing 9s, claiming 9s. That's why we trust our corner marks. Let's see. So what do I do with the fact that these aren't 7, 9, or that these aren't 2, 5? So this isn't 5. This isn't 2, 5. I'd really like to do something about that. Is our follow-up? Not that I'm seeing. I guess 5's in 2 places in this box now. Does the 2, 5 do anything? We're not going to have a 2, 3, 5 in this row. All right, maybe I'll just move on. Is this cell limited? We have this 2, 5 pair, so I'm going to look at this cell here. What can it actually be? It can be a 1. It can't be 2. It could be 3. It can't be 4, 5, 6, 7, 8, 9. So it is down to 1, 3. 3, 6. Huh. I'm just thinking about how this row is 1 through 6. This is limited then. This is just baseline from the row 1 through 6. It can't be 1. Could be 2. Can't be 3. Could be 4, 5. Can't be 6. So it's down to 2, 4, 5. It really feels like there's something to find here, but I'm not finding it. Let's look at this whole box. We need a 2, 3, 4, 5, 9. 2, 3, 4, 5, 9. This can't be 2 or 5. So 2, 3, 4, 5, 9. So, oh, it can't be 9 either. It's down to just 3, 4. It's not 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, down to 3, 4. 2, 3, 4, 5, 9. These aren't 4. 2, 3, 5, 9. So this is 2, 5, 9, I guess. I'm not quite finding anything useful here. Let's move on. Okay. I was doing columns. Maybe I should look at this column and this column. Let's start here. We know this isn't 4 or 6, so it's going to be marked. Is it? Well, this is down to 6 digits. For some reason, I thought it was down to 5. Well, this can't be 2, 4, 6. So this can be a 1. Oh, sorry. It can't be 1, 2, 3, 4. Could be 5. It's not 6. Could be 7 and 9. All right. This column is down to 1, 2, 3, 4, 8. So this is 1, 3, 8. 1, 2, 3, 4. 1, 2, 3, 8. 1, 2, 3, 8. All right. Still didn't find what I need. So the next kind of systematic step is to go box by box. And we're going to be thinking about a couple things. One is, do we just want to think about what's left in the box? Sometimes that's helpful, even if we're down to like 5. The other thing we're looking at is our corner marks and making sure they're getting respected. Are they respected within the box, and are they respected without the box? Outside of the box. So like these 3s pointing. Did I mark 3 anywhere that I shouldn't have? 1s and 5s. Oh yeah, so exactly what I'm talking about here. I have these corner marked 5s here, and I marked a 5 in this cell, so we should eliminate that. It's down to 7, 8 actually. I don't think that helps anything at the moment, unfortunately. But that's the exact kind of thing we're looking for. We had a lot of pointing at the start, so I wouldn't be surprised if I missed more. Let's just go through these in numerical order. So, is there anything special going on with 1 in this box? It's just in these 4 cells. I'm not going to see anything with that. The 2 is here. The 3, just making sure there wasn't anything I could have corner marked. The 4 is here. We don't have to worry about pointing there. 5 is here. 6 is here. Again, don't have to worry about pointing. I say that because we already have the 6 is placed and the 4 is placed. 7 is up here. 8 is here. And then 9 is here. So we did need to make sure that we didn't put 9 there and we don't put 9 here. So these not being 9, I wonder if that's enough to mark them up. So we'll do them both at once. We do need a 1. They can't be 2. We do need a 3. They can't be 4, 5, 6. This one can be 6. They can't be 7. This one can be 8. And they can't be 9. So yeah, they are worth marking. 136 and 138. So 279 are the other digits. I wonder if there's some geometry that I missed, that I've been missing. It doesn't seem like it, but I'm not sure what else to look at here. We're going to keep going box by box. So we have the 9s here. We penciled these just to bake in that 9. Is this cell worth marking? I don't think it is. Okay, we've got the 8s, we've got the 5s. 2, 5, 7, 9. 1, 2, 7, so the 1s are pointing. So these aren't 1. I don't know if that's enough to work with. 2, 4, 6, 5, 8. Huh. Not seeing it. Let's just double check anyway. They're not 1. They could be 2, 3. They're not 4. They could be 5. They're not 6. They could be 7. They're not 8. They could be 9. Yeah, there's just way too many options for these cells. 2, 3, 5, 7, 9. That's so many. All right. This box, we got the 1 and the 3. We got the 2. So these aren't 1. What if that makes this worth marking? It's not 1, 2, 3, 4, 5, 6. So it's from 7, 8, 9. So this can't be 1. It could be 2. It can't be 3, 4, 5. It could be 6, 7, or 9. Darn. This box is down to 5 digits. We need a 1, 3, 5, 7, 9. We have the evens. We need the odds. So these are 1, 3, 7, 9. There's just not anything useful here. All right. 4s, 6s, 8s. So it's not anything I missed in rows, columns, or boxes, at least that I saw. So there's going to be either something I missed in those systematic passes, or there's going to be a cell I need to mark that I haven't, or some geometry that I missed. 2, 3, 6, 3, 4, 6, 3 and 6. And 8, yeah. 1, 9. This 1, 9 felt important. The 2, 5 here felt important. Huh. This 7, 9 not being 2, 5 felt important, but I haven't found anything useful. What am I missing? 1, 6, 7, 8. 1, 6, 8. There it is. Okay. I've got 1, 6, and 8 in this box here. And this row does not have any of those placed yet. It needs a 1, it needs a 6, and it needs an 8. So I need to find at least three cells that I can put them in. They'll ultimately end up in exactly 3 cells, but we're going to see where they can go. Well, they can't repeat in this box because I already have a 1, 6, and an 8 in the box. They can't be on top of a 4 or a 7. So we're already down to 4 cells here. And this cell here is marked with 2, 5, so it can't be a 1, 6, or 8. You can see it sees 1, 6, 8 in the column. So actually, it's there from the start. It's just it's a tough one to spot. But that does mean that this is a hidden 1, 6, 8 triple. So what a hidden pair, hidden triple, hidden anything does is it removes the possibility of anything else being in those cells. I have to be able to place a 1, 6, and an 8 in purple, and so that it doesn't leave any room to put other digits in there. Like this can't be the 3, this can't be the 3, and this can't be the 5. It's only from 1, 6, 8. Okay. So I removed 3 and 3 from here. I removed 5 from here. So what did that do to 3 in this box? Unfortunately, we don't. The better question is, what did it do to 3 in this row? Because none of these are 3. That's not a 3. So 3 in this row is one of these two. So let's get rid of this color now. If 3 is in one of these two, that claims the box. The row needs a 3. It's going to end up here or here because we found that hidden 1, 6, 8 triple. And so as a result, this cannot be a 3 because the 3 is going to be here or here. So this is our 4. That removes 4 from here. So that places our 4 and our 6, which gives us the 8. Finishes this triple, the 3 and the 6. 3 in the corner, celebrating. Those aren't 6s. That is not a 6, placing the 6 here. That is not a 4. That is not an 8. Places the 8 in the box. That cannot be an 8. All right. Just got a bunch of digits. 3 in this box is one of these two. This is a 2, 5 pair. So that removes 5 from here. That's a 1, 8, and 5. Gives us the 3 here and the 1. This is now the only place for 8. This is now a hidden 7, 9 pair. And this is where the 4 goes. Over here we have the 7, which places the 8, which places the 5. We get the 9. Comes over here. Places the 9 in the column. I know there's another place for 9 in the box, but the column needed a 9. So it went right there. That's not a 9. This is 5. That places the 5 here. That's not a 5. So this is 2, 7, 9. And this is 2, 7, 9. That's not a 2. Here we get the 7, the 2, and the 5. Here we get 2 and 5. Here's a 1, 7 pair. This is not a 2. That places the 2. Now we're just wrapping up. This is 2, 3. This is 1, 2, 3. What's an easy place to look? This is a pair. This is 1, 3. This is an opportunity to talk about uniqueness. I'm not going to use it, but feel free to use it in your own solves if you'd like to. It's just never necessary in these puzzles, the New York Times ones, but it can certainly give you a boost if you find it. So here's the key. In my green cells, first of all, I have picked 4 green cells that occupy exactly, no more, no less, exactly 2 rows, 2 columns, and 2 boxes. I'm going to emphasize 2 boxes, not 4 boxes, 2 boxes. So I count that the green cells are in exactly 2 rows, 2 columns, and 2 boxes, making this rectangle. If I can confirm that's the case, the next thing that I need to confirm, basically, we know for a fact that because none of these are given, that's also an important bit, none of the cells have a given digit in them, they are not, there must be at least 3 unique digits within that rectangle. Basically, I can't make this a 1, 3 pair. Because if this is a 1, 3 pair, then in the row, there's a 1, 3 pair. In this row, there's a 1, 3 pair. In this column, there's a 1, 3 pair. In this column, there's a 1, 3 pair. In this box, there's a 1-3 pair, and in this box, there's a 1-3 pair. There's literally nowhere that would tell us whether we're supposed to resolve it with 1s here and 3s here, or with 3s here and 1s here. So either of those could be the solution, which means there's at least 2 solutions to the puzzle. But we know that there is only 1 solution to the puzzle. That's sort of an assumption we're adding when we use uniqueness techniques. And the New York Times puzzles always have only 1 solution. So as a result, we know we cannot make this a 1-3 pair, meaning one of these has to be a 2, and that places a 3 up here, because that can't be the 2. So that is a completely viable strategy to use if you are willing to add the assumption that there's a unique solution and willing to remove the cool property of a logical solve, which is that you've proven that your solution is the only solution. So anyway, one of these will be a 2, that'll be a 3. I doubt we're not going to need to use that to finish the puzzle, but I thought I'd take that opportunity to point out that technique for those who are interested. All right, this is a 2-6 pair. This can't be 6. So that's 2 and that's 6. And so now we know even further that this is a 2. This is down to 1-3 7. It's not 7. Clean this up a little bit. All right. We're missing a digit in this row. I noticed this is 1-3 7 9. So what's the other digit? 1 3. It's a 5. So we need a 5 in this row, which only goes here. And then these digits are 2 3 9. The 9 can only go here. Gives us 7 and 9 and 9 and 7 and 7 and 9 and 1 and 9. Gives us 7 and 1. That's not a 7. That places 7 here. 1-3 pair makes this a 2, which is what I predicted. That's 3 and that's 2. That's a 1. That's 3 and 1. That's 3 and 1. And this last digit's a 3. All right. Well, that took some time. It seems like we had to find that hidden triple. And it's not the easiest one to find, but it is available right at the start. So it's a little bit masked because we have a lot going on in these boxes. But noticing this 1-6-8 here had to go here is kind of the key to this puzzle. The only other way to move forward would be to have spotted that this was a 2-3-5-9 naked quad, which means that you'd have to pencil it all and then notice that. So that's kind of the bottleneck step there. Cool. Well, I hope it was helpful. I know it's a longer solve, but I hope it was helpful to see my thought process and the way that I approach when I'm stuck. I basically eliminated everything that could possibly be happening other than I missed some geometry or there's a cell I haven't penciled. And once I'm in that point, that's when I'm really looking hard at geometry because I'd rather not have to pencil everything and find quads. All right, well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.